Okay, this will be the final talk set of questions because I realized I didn't tell you about angled talks. So they're a little bit more tricky, but still you follow the same steps. 1, forces. 2, torque. 1, forces. 2, axis. 3, torque. Okay? It's just we have to figure out what the force is here. So, should I let you do it or should I do it first? I think I'll show you first for this question. Okay? So, when we do forces, we'll do forces now. So we got a force tension going this direction, and we got gravity pulling it down. Okay, so that's okay. We put our forces there, and now we're trying to choose our axis. So I'm going to choose P as our axis. Okay, so I'm trying to figure out what the tension is. That's the point of the question. Now, how do we resolve torques? We can't just say that T. Like usually, we resolve torques, and we'd go. So that's 1,000 newtons, right? So in this direction, how much torque is that doing around P? The distance is 1.2 times 1,000. Okay? Now, if we want to do it with the other one, looking at this, we want to do that. Unfortunately, it's going in this direction. So what we need to do is find the vertical component of this. Luckily, that's pretty easy to do because we have this triangle here. The vertical component of T will be this side, the height of it. Okay? Make sense? So if a tension like this, we just take this angle and we go this height, which is T sine 30. Okay? So effectively, we're saying this tension is pulling up in this way, or if we only care about the vertical part, it's effectively T sine 30 pulling it up. And now it's much easier. We go 0.8 times T sine 30. And now we make them equal each other. So that's 1200 equals sine 30 is a half, 0.4 T. Or T equals 3,000 newtons. I'm pretty sure this calculation is correct, but I don't have my calculator on me. So I think that should be right. So let me just check the last part. I guess I was wrong. Oh, massive beam. I forgot the massive beam. Okay, so if we add the massive beam in, it becomes 2,200 newtons down, multiplied by, what's the distance? 0.6. Okay? So the massive beam would be pulling it this way, so we add it here. Becomes 120 newtons. So that should be 1,320. So this will be, I can't do it in my head, but I'm assuming it's going to be that. Let me try and do it quickly. 1,320 divided by 0.4. Yep. Okay. 3,300. So that's the answer. So that's how you do these kind of rotating questions. And just for the sake of completeness, I'll do the rest of the questions now. Which one of the following best gives the magnitude of the torque on the beam about the point P? So they told us which axis. About the point P means our axis is P, due to the weight of the 100 kilogram mass. So we figured it out here. It was the distance 1.2 times 1,000, 1,200. Okay. Which one of the following best gives the sum of all the torques acting on the beam about point P? So this is our point P axis, and we know this is stationary. It's not falling down to the ground. That's what I'm assuming. You should probably read it. But that's what it's saying, I think. So that means we should have zero. There should be zero torque. If there was some torque, it would be moving down or it would be moving up. So it would be A. And we already solved the last question. So that's how you do most torque questions. You can apply the same principle of figuring out the vertical component and then make things much easier. Okay. All right. We'll catch you guys later. So, oh wait. Before I leave, when I say vertical, it doesn't always have to be vertical. It just has to be right angled to your line. Okay? It just has to look like this. So this looked like this. So what we did was we took the vertical part of that so it would look like this. Yeah. Okay. There. That's it. Catch you guys later.